Okay, this video is to record work for the calculations for the hydrogen lab, and this won't take us long at all. So we can get started right now. First of all, you would have recorded a certain volume of hydrogen from the tube in the simulation. Let's say that that's 42 milliliters, because that's what I got when I did it. Now, the first question is convert the milliliters of hydrogen gas by dividing it by 1,000. So that's 42 divided by 1,000, which then equals 0.042 liters, just a typical metric conversion, okay, like we've been doing. Now, the second question, determine the pressure of the dry gas by subtracting total pressure by the pressure of water. Okay, so let's go ahead and do that. So that's going to be 98.6 minus 3.17. I notice it says by the pressure of hydrogen here. This is supposed to be pressure of water, so let's fix that really quickly there. Okay, when I subtract that, I get 95.43, and that's in kilopascals. So we got to subtract the water pressure away because this was collected over water. Now our balanced equation is magnesium plus 2 hydrochloric acids makes magnesium chloride and hydrogen. So it's a 1-to-1 for our numbers up here. So we're going to do a two-step stoichiometry. And you would have recorded the mass of magnesium earlier, and that was 0.0393 grams. And that's grams of magnesium. Now, we haven't done two steps for you guys in class, but we're going to try it right now. The first step is going to convert this into moles. As always, we must always go to moles. So 1 mole of magnesium. I'm going to look at the periodic table to get its molar mass. That's 24.305 grams of magnesium. Okay, now we know this part, okay, where we just take our mole ratio, right? So I'm trying to find moles of hydrogen, so I put the word mole, and then H2 here, and then mole of magnesium there. I look up to my balanced equation. I see a 1 for my hydrogen, and I see a 1 for my magnesium. So it's a 1-to-1. So that equals, so all I got to do is take 0.0393 divided by 24.305, and that gets me 0.00162 moles. And that, of course, is hydrogen. Okay, so we're almost done. Now we have to use our ideal gas law equation, okay, to convert this moles to volume of hydrogen. And what we're trying to figure out is, in theory, how much hydrogen should we have gotten from this lab? Okay, so now I'm going to plug that into the pressure volume equals nRT equation. So our pressure we calculated to be 95.43. Volume, we're trying to figure that out. Equals N, which we just found, 0.00162. Our R constant, since we're in kilopascals, is 8.31. And our temperature is 25 Celsius or 298 Kelvin. Okay, now I need to get volume by itself. So I'm going to divide both sides by 95.43. So I'll divide this one by 95.43. That'll let me get volume all by itself. And the volume comes out to be 0.042 liters. That's exactly what we calculated above here. So I'm getting lucky this time, 0.042 and 0.042. Our last step is to determine our percent air. So this is what we're supposed to get for our hydrogen. What I actually measured in the experiment was 0.042. So I'm going to get a 0% air, because what we do is we take what we have minus what we're supposed to get, divided by what we're supposed to get, and then times that by 100. So that's 0. So this is a 0% air, which means to out to the thousands place we have a 0% air. So there could still be some errors in the experiments, like actually reading off of the gas tube that you see in the simulation. You might read it differently than 42, things like that. So that's it for our lab, and that's it for our school year. This is our last activity, kind of tying everything together. Okay, and if you have any questions, just let me know.